In the first video, we discussed what a subnet mask is and the format it takes. In this video, we'll discuss borrowing bits. We said that the first 3 octets of a Class C address have been assigned to us and we can't change them. We can work with the 8 bits in the last octet. We're going to borrow some of these bits and assign them to the subnet portion of the address. So what does it mean to borrow bits? We will assign some of the bits from the host portion of our Class C address to the subnet portion of the address. With an unsubnetted Class C address, we have 8 bits assigned to the host portion. We will use some of these 8 bits as the subnet portion of the address. By borrowing bits from the host portion of the address, we can create more subnets than we originally started with. However, each of these subnets will have fewer hosts than we originally started out with. With the Class C address, with one subnet, we can have 256 possible hosts. We're going to learn 4 rules for creating subnets. The first rule of subnetting is that we have to borrow at least 2 bits, and that we have to have at least 2 bits for the host portion of the address. We said that we have 8 bits in the last octet of the Class C address that we can work with, so using the first rule, we can borrow between 2 and 6 bits. So how do we decide just how many bits we're going to borrow to meet our goal? Binary numbering works on the powers of 2. 2 to the power of 0 is 1. 2 to the power of 1 is 2. 2 to the power of 2 is 4. 2 to the power of 3 is 8. 2 to the power of 4 is 16. 2 to the power of 5 is 32. 2 to the power of 6 is 64. And 2 to the power of 7 is 128. So that's 1, 2, 3, 4, 5, 6, 7, 8 places we have that correspond to the 8 bits in the last octet. This is an important concept. We're going to be working with these 8 numbers not as binary, but as decimal numbers. Notice that I didn't write any binary numbers, I wrote decimal numbers. We're going to be counting in decimal to determine just how many bits to borrow. We said that we need to have 4 offices, so we need to have 4 subnets. Our goal in this step is to come up with a number that's greater than the number of subnets we need. To determine how many bits we need to borrow, we need to start at the right-hand side of this group of numbers. Remember that when we subnet, we said we always have to borrow at least 2 bits, so we'll start with that. I'll add the value of the first number to the value of the second number. So that's 1 plus 2 equals 3. 3 is not larger than 4, so we know we have to borrow more bits to meet our goal. If we add the value of the next bit over, that's 1 plus 2 plus 4 equals 7. 7 is larger than 4, so we know that we have to borrow 3 bits to reach our goal in this scenario. Now that we've determined that we have to borrow 3 bits, we have to remember this number. We don't need to work with the number 7 again at any time during the rest of this exercise, so please disregard it. The default subnet mask for a Class C address is 255.255.255.0. The imaginary line is currently between the 3rd and 4th octets. The imaginary line divides the network portion of the address from the host portion of the address. We need to move this imaginary line to the new custom subnet mask for our scenario. The network portion of the address is represented by binary 1s in the subnet mask. We said that we have to borrow 3 bits from the 4th octet to meet the requirements of our scenario. The bits we borrow must come from the left-hand side of the 4th octet. We can't take the bits from the right-hand side of the octet since there's only one line separating the network portion from the host portion of the address. I know this confuses many students. After all, when we were determining just how many bits to borrow a moment ago, we were adding the numbers on the right-hand side. Remember that we were working with decimal numbers there, not binary numbers. All of the rest of the bits in the subnet mask line up to the left of the host bits. We need to make the bits that we borrow follow the same pattern, so we've borrowed the bits from the left-hand side of the last octet. This has the effect of moving the imaginary line over 3 spaces to the right. Now that we know where to put the 3 bits that we borrowed, we need to determine what the custom subnet mask will look like when it's written out. The default subnet mask had 24 bits turned on, and we've borrowed another 3 bits, so we could express our custom subnet mask as /27. Another way to express the custom subnet mask is to look at the value of the bits borrowed in the last octet. What decimal number does this binary number represent? Well, let's take a look at the values of each of the bits and add them up. The 128-bit is on, the 64-bit is on, the 32-bit is on. So if we add that up, that equals 224. So our custom subnet mask for this scenario becomes 255.255.255.224. That's the first part of the process. Now we need to determine the range of addresses in each of our subnets. We know that we need to borrow 3 bits for our scenario, and we know what the custom subnet mask is. We also have enough information to determine what the range of IP addresses are in each subnet. There's an easy way to get the number of usable subnets using the second rule of subnetting. If we raise 2 to the power of the number of bits we borrowed and then subtract 2, this gives us the number of usable subnets. We can't use the first subnet in the range because it contains the network or wire address, and we can't use the last subnet in the range because it contains the network broadcast address, so we subtract 2 to allow for this. We borrowed 3 bits for our scenario, so 2 to the power of 3 equals 8. 8 minus 2 equals 6. And we needed 4 subnets for our scenario. We have 6. Having a few extra subnets is okay because we can use them for future network expansion. The third rule of subnetting tells us that 2 to the power of the number of bits remaining minus 2 gives us the number of usable hosts per subnet. We can't use the first IP address in the range since that's the network or wire address for the subnet. And we can't use the last IP address in the range since that's the broadcast address for the subnet. When we apply the third rule of subnetting, 2 to the power of 5 equals 32. 32 minus 2 equals 30. So we end up with 30 usable hosts per subnet. Let's recap. Since we have a Class C address, we have 8 bits available for the host address. We borrow 3 of those host bits for the subnet portion of the address, and we have 5 bits remaining. Although we needed only 25 hosts and 4 subnets, it's always good to have a few extra hosts per subnet and a few extra subnets for future growth. In the next video, we'll be determining the range of addresses in each subnet.